So we are in Statistical Rethinking, second edition, chapter 14, and we're just starting the hard problems, question 14H1. So here's the question. So we're going to go back to one of the practice problems from chapter 13. I don't remember exactly what number it is, but we're dealing with the Bangladesh data set. And there we were modeling, and here as well, we were trying to model contraception use as a function of basically where by the district and some other things. So we're going to do that again. And but now we're going to use some of our new fancy tools. And specifically, we're going to use random intercepts and slopes for each district, okay? And the slope is going to be on urban areas versus non-urban areas within districts, okay? And we're going to wrap the intercept and the slope into a multivariate normal distribution. And from that multivariate normal distribution, we'll get an estimate of the intercept. We'll get that as well. But we'll get, among the things that we'll get estimates for is the correlation between the intercept and the slope, and we're meant to interpret it. So all that. It also suggests that we might get a better grasp of this if we do some plotting. But I think that this is straightforward enough that we don't need to plot. So I didn't bother with that, but I guess if you want some plots, I guess leave a comment and I will come back and revisit this and put the plots in. But I think it's straightforward enough that we don't need plots. So anyway, so first we need to get the Bangladesh data up. Okay, let me just say one more thing here, because I feel like I have not said this very often here in this playlist as of late. But if you're going to use this Colab sheet or your own Colab sheet, make sure that you come up to runtime, and you go to Jesus, it's been so long since I've done this. Manage sessions. Nope, that's not it. Let's see one more time. Change runtime type. And make sure that this runtime type is on R rather than Python. Okay. So, all right. So, and also, I forget to say this often now, but you need to make sure that you have Stan and the Rethinking package loaded and installed on your machine or in Colab. And so you can use this code in a Colab sheet in order to do that. You have to adjust it a little bit for if you're going to run it on your local machine. Okay. So we have the Bangladesh data up right here. Okay. And I'm just calling it D, and we're looking at the first bit of it. Okay. So we need to get us a few items in our data list. Okay. So we need urban. So these are all just from the question. So we need urban, whether or not a particular area is urban, or I should say, if a woman lives in a particular area of a district that's urban. Okay. We need whether or not contraception is used. So use contraception. And we also need the district, right? Because we're going to have random intercepts and slopes, for each district. Now, if you remember back in chapter 13, we had to do a little weird thing here because one of the districts is missing. So even though this is currently an integer, one of the districts, there's not a district for one of the numbers. I don't remember which one it is. And that causes problems with Stan. And so what you need to do is to first call it a factor and then call it an integer again. So when we call it a factor, we kind of smooth over that missing district. Okay, so we have the data list. And now we're going to set up the model here. So contraception, it's a Bernoulli random variable, or we can think of it as a binomial with n of 1. Okay, so that's what I'm using here. But I think we could also use, I think, D Bern gives us the Bernoulli distribution. But anyway, so now we're going to model P, and actually the logit of P here. Okay. So we have a intercept for each district and a slope of urban for each district. And then we're wrapping the priors, right? We're wrapping A and B up in this, for each district, in this multinormal distribution here. Okay. So now we have that the mean parameters for A and B, respectively, are mu A and mu B, and I've just set them here. And then the correlation matrix between A and B has a prior of LKJ correlation, or core 2. And again, what this is doing is it's making the model skeptical of a very high or very low correlation, near perfect correlations, positive or negative. Okay. And then sigma, which is basically the the variance of A and B. Okay. So I've already ran this, so we don't have to sit here and watch it run. And here is the outputs. So here's the output for the model. And when you run just this line right here, you get this, not really warning, but this message that says that that there's a lot of things that are being hidden from us here, and that's actually what I wanted. But we could get all of them by using depth 2 or depth 3. Okay, depth 2 gives you the individual intercepts for alpha and beta, and then if you go to depth 3, you actually get the correlate. You get the row matrix and so on. So, but this is good enough for our purposes here. Okay, so what we see basically is that the average effect of urban across all the districts is some positive value. So urban areas women in urban areas are more likely to use contraception. So that's what that's telling us right there. Okay. Now let's look at what we're supposed to do, or what we're supposed to be doing here is interpreting the correlation between alpha and beta, between A and B, the intercept and slope. So let's look for the correlation. So to get to it, I'm going to use, again, the Pricey function for model M. And now I need to go to depth equals 3 to get to the correlations. Okay, and so that I don't pull up absolutely everything, I'm just specifying I want row, right, the correlation for row. So if I just run this, right, just the highlighted section there, then I get all of this, the whole correlation matrix. But really, I just want the correlation between A and B, and that's here, okay, or here. These are equivalent, okay, right? The correlation of A with B is the same as the correlation between B with A. So I can just go to the second row, first column, and that gives me this value right here, okay? So what is this saying? Okay, well, so this is the correlation between A and B, and what this is saying is that, well, okay, let's take this this number here and this number here and kind of wrap it all together. So it's saying that urban areas, women in urban areas, are more likely to use contraception, right? But so the effect of being in an urban area is this, okay? But that effect, the effect of urban, decreases in districts that have a high baseline use of contraception, or or in the non-urban areas have a high contraception use. But if you think about it, this completely makes sense. So if you're looking at a district in which contraception use is used widely, regardless of whether people are living in urban or rural areas, well, then the effect of being in an urban area has to be diminished. It can't be any other way, right? And conversely, if you have low, either rural or baseline contraception use, well, now there's a lot of room for urbanization for urban to have a large effect on contraception use. So, so this correlation almost could not be any other way, I believe. And so I don't think that we need to plot anything. Okay, so this is this is just what, yeah, you can just read it straightforwardly. So anyway, we'll call it good.